Hello, everyone. Thank you so much for joining me this afternoon in the breakout room. The last session today of Code with Claude. I hope you've all had a fantastic day so far. My name is Margot van Laar. I am an applied AI engineer at Anthropic here in London. And this afternoon, we're going to be talking about the prompting playbook. And prompting is arguably one of the first skills, if not the first skill, that we had to learn as engineers when we first started to work with LLMs. And even now, it continues to be one of the most critical skills to building effective AI systems. So today, we're going to discuss some best practices in the context of two practical scenarios that you're probably encountering at work. The first is where you have an existing prompt in production that you've been maintaining for some time, and possibly you're migrating it to a new model or making a change to the architecture, and for some reason, it's no longer working as well. The second scenario is where we're building an entirely new agentic use case from the ground up, and we need to build the prompt from 0 to 1. Now, in order to illustrate these best practices, I don't just want to give you a list of do's and don'ts. I want to walk through a practical example that's been inspired by real prompts that I've seen some of our customers work with who are building on Claude. So the prompt that we'll look at today is a miniaturized example. The prompts that you're working with are probably a lot longer and more complex than the one we'll see today, but it's representative of some common problems that you might encounter when maintaining a prompt. So imagine that we have a prompt that multiple people have been collaborating on, contributing to. There's no clear owner. It covers a lot of different areas like policy, like tone, processes, and we have some patches for kind of previous models that we've migrated to, all mixed together. It's built up and it's complex. And when we're migrating to a new model, we're finding that suddenly a lot of our test cases are no longer working as well as we expected. So what's actually going on here? Well, in order to start unpacking that question, we need a starting point, and that starting point is evaluations. We need evaluations to provide that rigor to understand whether a change to our prompt is actually correlating to an improvement in its performance. And we have different models which have different capabilities and different behaviors. And when you migrate to a different model, it could be that your system is no longer working as well for two reasons. First of all, if the new model might be capable, but it's behaving differently, and therefore we can tune our prompting to fix that behavior. The second case is where actually the model that we're changing to isn't as capable, and no amount of prompting is going to fix that. So we need to have an eval suite to act as a way of testing that regression so that we can apply our prompting best practices to that. So in the example that we're going to be looking at today, as I said, it's going to be a miniaturized example. We'll have 5 test cases in our eval. In reality, you'll have a lot more test cases in your eval suite, but the key thing here is that it's representative of 3 key cases that we need to cover. Those 3 key cases include having a control case, which is a case which should always pass. It's something that we know the model handles well. It's unambiguous. The second is edge cases, and these are cases where we've seen the model fail before. And by including instructions into the prompt, we're making sure that same behavior doesn't slip through again in the future. And finally, and critically, we need to make sure that the model has a good understanding of the extent of its capabilities, where it should be handing off to a human, or where actually maybe it should be point blank refusing to answer a request. So in the example that we're going to be looking at today, we'll be using a prompt for a customer support bot for a telco company called Meridian Mobile. And these are the 5 test cases that we are going to be looking at today. We have a simple control case looking at, what's the data limit in the basic plan. We're also looking at edge cases, such as its ability to do calculations, such as calculating proration bills. If I switch my bill halfway through the month, or if I switch my plan halfway through the month, what will my bill look like? We want to check that it's accurately addressing key questions which are covered by our policy. We need to make sure that it's escalating to a human whenever there is a billing error. And finally, we want to make sure that our model isn't withholding any information that it has access to, which it should be handing over to the customer. So what we're going to do in this process is we'll take our prompt and we'll run it on our V0 of the eval. And we'll see what our failure modes are and systematically target those failure modes one at a time to see if we can resolve those failure modes by prompting. And along the way, we'll learn a little bit more about the kind of anti-patterns and traps to avoid. And this is representative of how we would apply these best prompting techniques in practice, right? We are rarely writing a prompt from scratch. We're often debugging an existing prompt. And best practice before we start targeting those failure modes specifically is to kind of apply our general prompting 101 best practices, applying general hygiene to clean up before we do the eval run. So let's have a little look at the example that we're going to be using. So what we're looking at here, first of all, before we look at the prompt, is just this vibe-coded web app that I've made for the presentation today so that we can look at how we're iterating on the prompt together. In this page here, I can easily run my evals on all 5 test cases and inspect the results in a little bit more detail. So before we have a look at the prompt, I'm just going to run the evals in the background. This is a pretty good first pass at a prompt. When we look at this, we've defined the bot's role at the top. When we scroll down, we've given it some data. We've given it some information on how to reason over the answers that it should be giving to the customer. It's giving some critical instructions around the tone it should use, how to do calculations, etc. And then finally, we're passing in our customer account context and our user message. So let's have a look at how our first pass at the evals did. So we can see, as we expect, our control case, all of our test cases have passed. This is what we expect for this unambiguous test case. But it's performing pretty poorly in these other areas. Now, before we zoom in on those specific failure modes here, let's do some general cleanup of our prompt. So as we mentioned, when we look through this prompt, there's a couple oddities here already. So for example, the first one is we're telling the bot that it's a human, which just isn't true, right? We can see as we scroll down, there's clearly some information here that has been copied directly from a website. So the key giveaway here is a reference to a hero image. There's even some references to cookies at the bottom. So we need to remove a bit of redundant information. When we look at the instructions here, they're all grouped into one big paragraph. So we've got some reasoning here, we've got instructions about the role, some critical instructions as well, without a real way of unpacking policy from guidelines, from tone, etc. So let me just... I've preempted some changes we want to make to this prompt, and this is just a diff view of some of those changes. So what we've done is, first of all, added some structure. So you can see that we've added XML tags here to define the role, to separate general guidelines, to separate policy, to separate tone of voice, etc. So if we run that eval then on this new updated prompt, we should hopefully see an improvement in the output as is. So we can see just by clearing up the prompt, we've already improved the model's performance on this prepaid scenario. There's an interesting regression there in that fifth hotspot case, and I don't want to worry too much about that now. There's going to be some natural level of variance in the different runs of the eval, and we'll come back to that case specifically to see if we can make the prompt consistently better in that area. So what did we learn from this then? Simply clearing up the prompt with a better structure, with a better role description, has improved the performance. And this is a best practice that you can return to at any stage of writing and maintaining your prompts, especially as your prompts get more detailed and more complex. A general rule of thumb that I like to follow is if you're reading a prompt and you can't tell guidelines from policy, from data, most likely the model isn't able to either. So before looking at some of those cases in more detail, there's a little bit more general cleanup we can do, specifically here looking at creating an output contract. This is a key best practice to follow if you're struggling with your output format consistency. Now, in this case, we have a customer support bot. We want it to reply in a conversational tone, so it's unlikely to be a big issue in this case, but it's something to bear in mind if you're dealing with more complex output structures like nested JSONs, for example. So again, if we go back to the prompt and see what fixes we can apply here, first of all, we've added a section at the end where we've defined an output format for the model, telling it to use XML tags to output the response. But the prompt is not always the most effective way of handling issues. We can also change things in the harness to ensure consistency to a higher degree. So what we've added here to the API call is a stop sequence, which is going to detect that closing XML tag and tell the model to stop generating a response at that point. Now, when I run the eval here, I don't necessarily expect to see any clear improvement in performance, but it's a general best practice that we should be following, and as I said, is something that we should remember, in particular when we have more complex output schemas. One thing to point out here as well, if you do have a more complex output schema, something like structured outputs can be incredibly helpful to ensure that consistency in a more programmatic way. Okay, so after the cleanup then, we can see that we now have 2 test cases which are consistently passing, but we have 3 key failure modes: the proration, the billing error, and the hotspot. So let's isolate these one by one to iterate on the prompt and see the effect of that. First of all, then, the hotspot question. So the question is, how much hotspot data is on my unlimited plan? What we expect the model to do is state directly the amount of hotspot data that the customer has. And the reason this is a slightly complex case is because the customer test case that we're dealing with is on a legacy plan. So actually, the current policy doesn't apply to them. So if we see what's going on in the actual test case here, the customer data which we're feeding to the prompt includes the amount of hotspot data that customer has. They have 5 gigabytes, right? But they also have a grandfathered plan. So what we're seeing the model is actually telling the customer is the general, the unlimited plan